Hi, everybody. This is the homework assignment that you had. Now, the first thing I did here was I clarified what the values were. Whereas this right here should be about 32, this one is 8. This should have been about 9.2, 24, 8. This one was 3, 2, 1, 2, 3. And this one was 5.1, and this one was 7. So that's just in case you cannot read the numbers. And if you didn't see, this 11 goes right here. So the idea is we have these circuits and they're series or parallel. They're not a combination. And you know which one by the notes, which one they are. So we have to take a look at one series and one parallel. So what I'm going to look at is I'm going to look at problem number 1 and then probably problem number 5. So we're going to look at those two and see how to do them. Then after that, I think you're going to be able to follow the pattern and be able to finish it for Monday. So let's take a look at this. Now for number 1, you have, here's number 1, and we have a 32 volt battery right here, and the potential difference across the battery is 32. Then it comes around to a 6 ohm resistor, and then it comes around to an 8 ohm resistor. Now, when you're taking a look at this, we're going to make a chart. The chart is going to look like this. Across the top, we're going to put V equals IR. And whose law is that? Yep, you're right. That's Ohm's law. Now, what we need to do is list the components that we have. Now, notice how many components we have. We have 1, 2, 3 components here. So when you're looking at these components, you can see that we have to deal with 3 different things. Now, the first thing we're going to do is we're going to deal with the 2 resistors. Now, we're going to call this one R1, and this one right here is R1. Doesn't matter, it's arbitrary, but I'm just going to follow this way. The other one we're going to call R2. The battery part, this thing right here, well, we learned from the lab that that's the total voltage. So we're going to call that R total. Now, sometimes that is also called R equivalent. Same thing. I just like total because it's a little easier. At this point, it's like a big Sudoku puzzle. You want to try to fill in the boxes as you go. Like R1 here, I'm going to say is 6 ohms. R2, well, I'm going to call this one over here R2. I'm going to call that 8 ohms. Now, the total resistance, I don't know. I don't know the current. I don't know the voltage. Oh, wait, I do. The voltage right here, you can see, is 32. That's the total voltage, the most I can have. Remember from the lab? This voltage stayed the same. Now, I'm going to put 32 right here. And I'm going to change colors because at this point I had to start solving the puzzle. If you look at a series circuit, what do I know? Well, I know that the resistance adds, so 6 plus 8 is 14 ohms. Now, wait a minute. If that's 14 ohms, then I can solve for the current. Now, how can I do that? Well, voltage right here equals current times resistance. So therefore, voltage divided by resistance should give me current. So if that's true, I would just have to do 32 divided by 14, and that would give me a value of, I believe, 2.29. Now wait a minute. This is a series circuit. What do I know is constant in series? Well, that's current. So each one of these is 2.29. Then after that, well, how do I find the voltage? Well, R times I is the voltage. So all I have to do is multiply 6 times 2.29 and 8 times 2.29. Now, if you do that, you should get the values of 13.7 and 18.3. And just give me 3 sig figs on these, please. So this is 18.3. Now, how do I know if this is right? Sorry about the 18.3 there. Well, if I add these together, they will add up to 32, because in series, the voltage adds. Now, I think you can follow the pattern for the rest of the series. If there's more than one resistor, you just have to do an R3, then an R total, then etc. Now, if we look on the next slide, let's take a look at, I don't know, let's look at 5. So if I look at 5, here's 5. 5 has a total voltage of 12 volts, which goes to 3 ohms, goes to 3 ohms, and then back to the 12 volts. All right. So what do we do with this? Well, we make our chart again. That's our little friend. I'm going to do V equals IR, and then make our little chart here. And then we have to take a look at how many resistors we have. Well, we've got 2. We've got 1, 2 resistors, right? So if that's true, then what I'm going to do is I'm going to put R1 all the way over here. I'm going to put R2, and if there aren't any more resistors, then we have our total or equivalent resistance. Now, this is 3. This is 3. Doesn't matter. They're both the same. And then where do I put this 12 that's over here? Well, this 12 is still my total. So I'm going to put the 12 right here. Now, at this point, that's all the information I've given. So how can I solve this? Well, there's 2 ways, in my opinion. First thing I could do is I could just say, well, what's the one thing that is constant in parallel? Well, that's voltage. So if that's constant, that tells me that all of these are 12. Well, if that's true, then I can just use, well, let's see. V divided by R would give me I, because V equals IR. That's Ohm's law. So if that's true, I can then do 12 divided by 3, which is 4. 12 divided by 3, which is 4. If you add this together, why would I add these 2 together? And what am I pointing to? Well, I'm pointing to these 2 here. Because in parallel, the current adds. So 4 plus 4 turns out to be 8. Now, how do I get the resistance right here? Well, I could use Ohm's law and go V divided by I is R. So that would give me 12/8. So 12 divided by 8, which reduces down to what? Well, that reduces down to 3/2, which is 1.5. Now, the other way I could do it is we know that in parallel, this and this, these resistors add as that inverse equation. Now, I want to practice this to see if I get the same answer here. So, if I do that, I would go 1 over RT equals, that's a T, sorry, equals 1 over 3 plus 1 over 3. Well, that means 1 over RT is equal to 2/3. Now, most people think, wait, those are 2 different answers. 3/2, 2/3. Except, take a look. This is 1 over RT. So to solve, I have to take the inverse of this, which means I have to flip both sides. So if I flip both sides, I would get RT equals 3/2, which is the exact same answer as we predicted above. So you could have also just found the resistance and found the current, and you would have gotten 8 too. That would have worked just as well. So this is all you need to do to solve for series or parallel. You have to use the chart we determined in class, and then you have to just use the VIR chart to solve. That's all you need to do. So hopefully this will help, and I would like you to get 1 through 8 done for Monday. Thank you.